Good morning, students. I hope I'm audible.
Yes, ma'am.
Yeah. So till previous class, we have discussed the algorithms and the derivative with respect to how to draw a line, and then we started with the circle, and finally we are done with the ellipse, right? So in today's class, we are going to see given a polygon, how we are going to fill the color into that polygon, like the polygon which has different any number of edges, which is a closed figure, and you want to ensure that how you can fill the color into the given polygon. So that we'll be discussing. So before we start, let's see what you mean by polygon. So as I mentioned, a polygon is a closed figure. Any example you can give for polygon?
Triangle, rectangle, pentagon, hexagon, octagon,
Yes.
polygons.
Yes. So all closed figures, right? So whatever your friend mentioned, like triangle, rectangle, octagon, and so on. So all those things, the one thing which have in common is they are all closed figure. So hence we are going to call it as a polygon, and poly is nothing but many, right? You have many edges in this. So closed figure with at least 3 edges. Minimum, it need to have 3 edges. So before I start with area filling algorithm, I'll do some background and then we'll continue with the algorithm. Okay. So polygon is a
And
closed figure with at least 3 edges. Yeah.
also all the sides need to be straight lines.
Yes. All the sides need to be straight line. So your example, as your friend mentioned, it can be a triangle, a square, rectangle, and etc. Okay. So in polygon, you have two different types. Okay, the types is just based on how we are going to design it. Say for example, this is a polygon, right? Because it is closed, you have edges like 1, 2, 3, 4, and 5. You have 5 edges and it is closed. Hence, we can call it as a polygon. So let's just number it P1. Okay, what type of polygon is this? We are going to call it as a simple polygon. So basically, you have one starting point. You're going to draw a closed figure with the help of the straight edges. And once you come back to the position or the vertex where you have started drawing your diagram or your figure, okay, then you can say once the cycle is completed, you can see that it is a polygon and hence it is closed. Wherein P0, the start and the end is P0 itself. So same thing, say for example, I have things like this. So we have 4 points. So let's say we joined P0, P1, and there is a edge from P0 to P3 and P3 to P2. And because we want to make it close, let's say there is a edge from P1 to sorry. So there is an edge from P1 to P3. So this is again a closed polygon, and here also you can say the start and edge is same. Okay, for P0 to P1, P1 to P2, P2 to P3, and P3 to P0 again. Okay, but you can see that the edges are going to intersect with the another edge in the figure. So such diagram or such polygon is known as a complex polygon. Fine. So what we discussed, definition for polygon, it is nothing but a closed figure with at least 3 edges, and we saw few examples. And again, your polygon can be of different types based on how you are going to draw that figure. In this case, it is a simple polygon where the edges do not intersect. This is a complex polygon where the edges intersect, and other property which is a closed one, so that holds for both. So next, the major difference, okay, type of the polygon. You have convex polygon and concave polygon. Do you have any idea what do you mean by convex and concave polygon? Okay, so in case of a convex polygon, let's say example I'll take. I have a triangle. Okay. So if you're going to draw a line segment, okay, if you're going to draw a line segment joining any 2 points within the polygon. So this is my polygon. Within a polygon, let's say I have 2 points. You can have the points anywhere, but ensure that it is within the polygon. Okay, a line segment joining any 2 points within the polygon lies completely inside the polygon. Okay, no matter where you have which point you select. Okay, a point which is inside a polygon, no matter where you select, it will be within the polygon. Say for example, I select this and somewhere here again. So whatever line you are going to draw, it is within a polygon. So such polygon are said to be convex polygon. Okay, a line segment joining any 2 points within the polygon lies completely inside the polygon is known as convex polygon. Next, one more property in convex polygon is whatever angle you have, okay, whatever angle you are going to get between the edges. So the angle will be always less than 180 degree in case of convex polygon. So that is one more property. First property, no matter which two pair of points you select within your polygon, the line segment lies inside the polygon. Second property, between the edges, whatever angle you have, that angle will be always less than 180 degree. Similarly, in case of concave, it is just opposite of this. The line segment is outside the polygon. Here what we have said, any 2 point, the line segment is always inside polygon. In case of concave polygon, the line segment will be outside the polygon. So let's see. I'll take this one, right? So here, okay, so I have selected these 2 points. Okay, in this case, it is inside the polygon. But if I select points like this, right? In this case, you can see the part of the line is outside your polygon. Hence, no matter whether how many lines are outside, if at least one line is outside your polygon, which means it is concave polygon. And in this case, the angle, okay, so this is the angle between the edges. This is inside polygon. If it is straight line, then it will be 180 degree because we are taking complete. So this angle, at least one angle, okay, will be greater than 180 degree. So this is a property for your concave polygon. I hope it's clear. So we have two types of polygon based on where the line segment resides, right? So you're going to select 2 points, any 2 points inside your polygon and draw a line segment and see where the line segment lies. If all the line segment lies within the polygon, then it is convex and the angle between the edges will be always less than 180 degree. In case of a concave, if at least any one line segment which lies outside your polygon, then you can say it is a concave polygon and here the angle will be greater than 180 degree. Is it clear? Okay, so this will be used later on again. The next is representation of the polygon in computer graphics. So there are three ways you can represent your polygon. So first is polygon drawing primitive approach. In this approach, you can directly draw the polygon shape on a device and they are saved as one unit. Okay. Say for example, you are trying to draw a line using some application, desktop application which is installed in your device maybe. Okay, and there you are going to do a drag and drop. So you are going to select a polygon and you are going to directly use it. It will say for example you want to insert a polygon into your image, into your diagram, then so into a canvas, then what it asks for is it is going to ask, okay, how many edges you want. Say for example you select 5 edges, then it is going to draw a polygon on its own, and while drawing it is going to ensure that all 5 edges are of same size and have a same angle between the edges. So that is polygon drawing primitive. Yeah.
Thank you for talking. The JFL. Awesome.
What happened? Yes, please mute yourself while in class. Only if you have query you can ask. Okay. Okay. So this is a polygon drawing algorithm, right? Wherein you have a fixed number of, you can specify a number of lines and it is going to draw a line on its own. Okay, you don't have a control over it. So it is going to draw a diagram on its own wherein it is keeping all the edges of the same size and angle between the edges are also equal. And next is trapezoid primitive approach. So in this case, you are going to draw a polygon. Say for example, my polygon shape is something like this. Okay. Say for example, this is our polygon. So what it does in order to represent this in your computer graphics. So let's say these are our scan lines. Okay, and this is the image which you want to draw, right? So this is the same polygon which you are trying to draw. So what it does is, so with respect to scan line, wherever your edge intersects, right? So it, say for example, it intersected over here. It is going to take pair of edges, these two and these two. And it is going to consider this entire thing as one trapezoid, right? So pair of scan lines it is going to consider, and it is going to take the point where the edges intersect with your scan line, and then it is going to draw a line. So in this way it is going to draw a series of trapezoid. Okay, so polygon, instead of drawing one polygon, it is going to consider it as a series of trapezoid and draw it as a series of as a series of as a series of trapezoid. So trapezoid is always has four side, 1, 2, 3, 4. Okay, it always has four side, and it will have one pair in parallel. So parallel line will be your scan line, this one. Okay, so this will form a trapezoid which has four side, and one more condition is one pair should be parallel. So in this case the condition is satisfied. So this is one trapezoid. If you consider this, then it will become second trapezoid and so on. So wherever you don't have a complete trapezoid, then your system is going to interpret that this is the end of your figure, right? And this is just a vertex which it is going to consider. So this may not be looking like a trapezoid, but it is going to help the system identify the end of your particular polygon, right? So that is with respect to trapezoid primitive approach. So whatever polygon you are trying to draw, it is going to draw it as a series of trapezoid. So finally, the one which we are going to focus on is line and point approach. So in line and point approach, you are going to write an operation code. Okay, you are going to write a set of command or an instruction, and you are going to specify, okay, which line, the vertex of each line, okay, the start and end point of the line, which helps you to know the location of the line, and which line is followed by which one. You are going to specify whether it is adjacent to particular edge or opposite to a edge. So all those things can be specified by the user in case of line and point approach. So we are going to discuss an algorithm based on this. So basically we have three approach. In a first approach, directly you are going to draw a polygon. You will not have a control over it. Entire polygon will be drawn. Okay, you can just resize it, and every edges will be of the same shape, same size. In trapezoid primitive, the polygon will be represent as a series of trapezoids while drawing in your graphical interface. Next, in line and point approach, we are going to write a set of instructions specifying where the particular line will be drawn onto your screen. Fine, is it clear? So we are going to see algorithm for line and point approach. Okay, so this is an algorithm for line and point approach. So first you are going to read AX and AI. So what do you mean by AX and AI in this case? AX and AY are array containing vertices. Okay, because you have X coordinate, you have Y coordinate, right? Each vertex will have X and Y coordinate. All X coordinate will be stored in AX array in a form of array, and all Y coordinate will be stored in AY in the form of array. Then of length n, where n specifies the number of sides in your polygon. So let's consider one example for this. So hexagon I'm considering here, so which has 6 sides. So let's specify the coordinates for each side, as for each vertex.
What does DF stand for?
It's a display buffer file. Okay, D and F. I'll come to that. I'll just finish this. Okay, so for example, this is a polygon which we are trying to draw. Okay, so in order to draw it, we are going to make use of something called as a display buffer file. Your display buffer file will be consisting of sorry, display buffer file opcode. Okay, opcode is nothing but a set of instruction. DFOP is nothing but display buffer file opcode, a file consisting of instructions. The instruction, what instruction it consists of. And then display buffer file consisting of the value of your x coordinate and the value of your, y coordinate. Fine, so we are already using it over there. Okay, so initially in a display buffer file, first you have to initialize it, right? So how we are going to initialize it? First you are going to consider how many edges, right? Because you want to go for drawing a pentagon, sorry, hexagon here. Hence the number of edges will be 6. So here the first instruction represent a number of sides. Okay, so here 6 represent number of sides, and so where you are going to start with I equal to 0. So let's say we are starting it from this point. For I equal to 0, what is your x and y coordinate? So first coordinate value you need to specify. So it is 0 and it is 2. Okay, first coordinate value is 0 and 2. So we are over here. Okay, so initially I equal to 0, and you are going to assign a value. So what is the value here? So first operation, so first opcode is 6, which means you are specifying, okay, we are going to draw a hexagon in this case, which has 6 edges. And then you are going to specify the starting coordinate. So here the starting coordinate x value and a y value. In this case, it is 0 and 2. Okay, next you are going to just increment your I value to I plus 1. So let's say it will go here. Right? So we did I plus 1. So now it is over here. And we have a condition of do while condition here. So what is the condition? While I is less than 6. Okay, so this you are going to continue till your I is less than it is going to do execute this once and then going to check the condition. Okay, that you have to remember. It will execute and then check the condition. When I is less than n, when I is equal to n, it is going to come out of this loop. When I is equal to n, it is going to come out of this do while loop. So what we have written in this do while loop. So first instruction, as you can see, you have df, that is your display buffer file, opcode. So what is the instruction written here is to. So in this case, to signifies that you are trying to draw a line. So to specifies line. In order to draw a line, you need two vertex. So in this case, to specifies that you are going to draw a line. To specifies line, and then you are going to specify the coordinates. I is already incremented for I equal to 1. So what is the coordinate you want to give? Okay, that you are going to specify. What's the coordinate in this case? I equal to 1. We have coordinate value as 0 and 4. And you have given instruction that there is a need to draw a line. So initial coordinate is already given, that is 0 and 2. Next you are saying 0 and 4. So this line will be drawn. Okay. So this thing again, your I is going to be incremented. So now I is 3. Okay, 3. And again, you are going to specify, you want to draw a line which is 2. And what is the coordinate you want to consider in this case? It is, sorry, I've done a mistake here, no? We have 1, 2, sorry, 3, 4, and a 5. So totally 6 sets because we are starting it from 0. So next coordinate what we have is 4 and 6. So next it is going to draw from 0, 4 to 4 and 6. This line, again you are going to increment your I value and you want to draw a line, hence 2. And the next coordinate is 6 and 4. You're going to draw that line. Again increment your X. You want to draw a line. Next is 6 and 2. Again, we are going to increment line and the next coordinate value is 4 and 0. Okay. So, okay, I think I have to extend it. So next, so once it's done, what's the value of I in this case? I is equal to 5. I is equal to 5. Okay, because here, sorry, in this condition, it is less than n. So this condition is satisfied. So now, because you have incremented your I, right? See, at this moment, what happened? 4 equal to 0. It is 4, it is 0, you incremented I. Now I has become 6. Now I has become 6. So condition is, now we are going to check the condition. So when I equal to 6, is it less than 6? No, because it is equal to 6. So you will come out of this loop and you are going to execute this. Again, in this case, you have instruction as 2. You again want to draw a line. Okay, where you are going to draw a line. So what they have mentioned is whatever the starting point. So the same point I want to consider because you are going for a closed figure, right? So same coordinate is considered, that is ax of 0, ay of 0. So in this case, that is equal to 0 and 2. So this is our stopping condition. So here you are going to stop. So your display buffer file, you are going to specify the instruction and you are going to specify the coordinates for x and y value. So this is how you can enter into your polygon, right? So how you actually you are going to draw your polygon. So this is a thing, this is a algorithm behind that. Is it clear?
Yes,
Just
ma'am.
go through that. If you have doubt, you can ask and take down this. So these are all background. Whatever I am discussing now, these are all background for your area fill algorithm. So before you know how to fill the area inside your polygon, you need to know how to draw or enter your polygon, right? Only then we can go for area filling. Okay, can I change slide?
2 minutes, ma'am.
Yeah.
Okay, ma'am.
Yeah. So next is an inside test. So what do you mean by inside test? So in this case, you are going to check if the pixel is part of the polygon. Okay. So for example, I have a polygon. Let's consider a triangle. So you're going to check, okay, if this is a point, you want to ensure whether this point lies inside the polygon or is it a point outside the polygon. So why we need this? Because you want to color your pixel which is inside your polygon. You want to um, fill the pixel inside your polygon. So in order to ensure whether the pixel lies inside or outside, you need to make use of a test. So that test is known as an inside test. So it is used to check if the pixel is part of the polygon. I'll just write it here. To check if the pixel is part of polygon. Fine. So here we have two different methods to do that. So first method is odd even method or even odd method or odd parity. So different names for that. Or odd parity. So in this case, you want to construct a line, you are going to construct a line segment between the point in question. Point in question in the sense, the point for which you want to decide whether it lies inside the polygon or outside the polygon. Okay, you are going to draw a line segment between the point in question and a point known to be outside the polygon. For a given polygon, you are going to draw a line. So let's just consider with the example, it will be clear. So let's take one example. Okay, any polygon. Okay, this is one polygon. Okay, so now you are going to select one point. Say my point is this, and I'm going to represent it as X. So this is a point in question. So what is specifying is you are going to construct a line segment between the point in question and a point known to be outside the polygon. Let's say outside the polygon, somewhere here we have a point. So what you're going to do, you're going to draw a line segment like this. Okay. So once this is done, then you're going to count the intersection of the line with polygon boundary. Okay, whatever line you have drawn, you are going to count the number of intersection with the polygon boundary. How many we have? We have one. Okay, so this is 1, 2, and 3. You're going to count the number of intersection point with the polygon boundary, It is said to be inside if odd number of intersection is there. Okay, and it is said to be outside for even number. So this is an example wherein we have considered a point which is inside the polygon. Let's consider a point which is outside the polygon. So this is a point which is outside polygon for which you want to decide, and one more point for which you know that it is outside a polygon. You are going to draw a line segment. So in this case, the number of intersection point is even. Okay, so even intersection, and here it is odd. It is even number of intersection. Fine, so this is a case, and if the points are on the same side of the constructed line, then the even number of intersection for only that. Okay, so let's say I have something like this, a point over here, and you're trying to draw a line. While drawing a line, okay, so while here we have one more point, that is x, okay, and you have something at the outside or some point at the outside. How many intersection point you have? You have one and you have two. It is satisfying this, wherein when you have even number of potential, it is outside, but you're not going to consider it as outside. Why? Because here you are not intersecting with the edge of the polygon. Instead, you are intersecting with the vertex of the polygon. And one more thing, when you're intersecting with the vertex of the polygon, you have to first check, okay, whether that whether the edge joining the vertex of the polygon, we have edge here, let's say I'll just give some name to this, v1, v2, v3, right? So here we have two edges, let's say E1 and E2. So E1 and E2, two edges which joins your vertex V1, okay, they are at the same side, okay. So both E1 and E2 are at the same side of your line segment. In that case, you are going to consider it as, you are going to consider it as inside the polygon if the points are on the same. Okay, then you are going to consider it as inside the polygon. Say for example, if it was something like this, you have a point. If it is something like this, at that time it is going to consider it as a outside the polygon, because in this case, say for example, it is something like this and you are cutting something like this, your line segment is like this. So in this case, so both edges are at a opposite direction. Okay, so we are going to consider it as a odd number, right? Whereas here you are going to consider it as a even. Sorry, it's the same diagram, right? Yeah, so here we can consider it as a even number of intersection, and here we can consider it as a odd number of intersection. Is it clear?
Yes, ma'am.
Yeah. So why I have discussed this is because here you are not intersecting with just edges, you are intersecting with the vertex. At that time you have to see, okay, how many edges I have over here, right? You are going to check how many edges I have. Okay, in this I have 1, 2, and both the edges are at the same side of your line segment. So there it is considered as a even. So even number of edge, even, say whatever number it is even plus 1, so that will be odd, so hence it is inside the polygon. And if the edges are something like this, something like this at the opposite direction, then it is considered as a odd. So odd plus 1. So odd plus 1 is even. So when it is even number of intersection, it is outside the polygon. So this is a case, right? Okay, so this is one method, and second method is this winding number method or non-zero winding number method. Okay, so in this case, statement diagram. Let's assume everything is a straight line here. So winding number method. So it is nothing but you are going to whatever polygon you have. Okay, in this case you are going to just wrap around this particular polygon. Say for example, when you do a wrapping, okay, you are going to do a wrapping around your particular polygon. So in this case, when you are doing a wrapping around the polygon, okay, and so this is a wrapping which we have done. Now we are going to select a point. Say for example, let's say our point is over here. Okay, and you are going to draw the line segment. So this is a line segment. So here you are going to count the line intersecting with your whatever winding you have done. Okay, I can better write a algorithm. Short algorithm I'll write here. So first what you are going to do is initialize the winding count. Okay, winding number is equal to 0. We are going to initialize it to 0, and then you are going to draw a line from your questioning point to the known point which is outside your polygon, and draw line segment. I'll write. Draw line segment, and then if the line crosses a edge, if the line crosses an edge, directed bottom to top, okay, if it is directed bottom to top from down to up, then you are going to add 1. Okay, add 1 to your winding number, and if it is going from top to bottom, you are going to add minus 1 to your winding number. Okay, so what we are doing here, initially we are initializing our count as winding number is equal to 0. Okay, and then you are going to draw a line segment from you're going to draw a line segment from your questioning point. So in this case, the questioning point is this to your point which is outside your polygon, and then you're going to check if the line crosses an edge directed bottom to top, then add 1 to it. So these are all my edges. So in this case, this edge is going what? Say for example, you have to give direction here. So let's say it can be clockwise or anti-clockwise, any one direction you can consider. So let's say I'm considering anti-clockwise. So in this case, if the line crosses an edge directed bottom to top, right? So bottom to top. So this is bottom to top. In this case, you are going to add 1 to your winding number. So initially it is 0. So now it became, initially your winding number was 0, right? So now it will become +1, right? And then you have one more edge, which is what? And if you have a edge which is directed from top to bottom, you're supposed to add -1. So we'll do -1. And in case of right to left, no change. Okay. Uh, Left to right or right to left, no change. In case of left to right edge or right to left edge, there is no change, so need not worry. Only wherever it intersect, okay, you are going to check if at the intersecting point, if you have an edge from bottom to top, which is going bottom to top or top to bottom. If you have, then what you're going to do, if it is bottom to up, you are going to add 1. If it is top to bottom, then you are going to add -1. So in this case, the final value for your winding number is equal to 0. So whenever your winding number value is equal to 0, which means the point lies outside. And if you have a winding number value, okay, I can just say otherwise it is inside. Okay, if it is equal to 0, then outside, else inside. Fine, this is a condition. So in first one, what we did, we are going to consider the intersection point between the questioning point and the known point, which is outside. You are going to draw a line segment, check the number of intersection point. If the number of intersection point is odd, which means your questioning point is inside the polygon. If number of intersection is even, which means it is outside the polygon. Then in winding number method or a non-zero winding number method, first you are going to initialize it to be 0. You are going to draw a line segment same way as this. You will have a questioning point, you will have a point outside your polygon, draw a line segment and see wherever it intersects your edges. Then if there is left to right or right to left edges, you need not worry, you can just ignore it. And if you have top to bottom or bottom to up, if the edges are going in that direction, and that case, if it is bottom to up, top, then you are going to add 1, and if it is top to bottom, you are going to subtract 1. So in this way, a final value, whatever you get, you are going to see if it is equal to 0, which means it is outside your polygon, and if it is any value other than 0, which means the point lies inside the polygon. Fine. So this is a test with respect to the pixel, to check if the pixel is part of your polygon. Is it clear? Just go through it again and see if you have any questions.
Excuse me, ma'am.
Yeah.
If the line passes through horizontal lines,
Horizontal line, yeah.
then it would be left to right or right to left, right?
Yeah, correct. This one, na?
Yeah.
Yeah, it will be left. So you are not going to do any change. So initial value is 0, it will still remain 0. Hence it is outside.
But in case of a square, it would be wrong, right?
Okay, let's consider square. Okay. Yeah, and where is your questioning point? Where you want to keep it?
The bottom.
Here?
No, below the square. Yeah.
Here?
Yeah.
So this is our x.
And the known point will be above.
Here?
Yeah.
Because your known point need to be here. In this case, it is okay. In this case, it is going to intersect, but the thing is, yeah, left to right and right to left, and hence it is no change. Okay, and we know that initial value of our winding number is 0. It will remain 0 only. And when it is 0, we have already mentioned that it is outside your polygon. And it
Okay,
is outside polygon.
if it is inside, then if questioning point is inside.
If the questioning point is inside.
Inside and right under.
Yeah. Ha ha
Yeah.
ha. Okay. Yes, here uh, left to right. It is left to right. Left to right with respect to this line we have to consider. Okay, see here, in this case, this is our line segment and these are our edges, right? So these edges with respect to line segment, it is top, bottom to top. And similarly, if I consider with respect to line segment, our line segment itself is going like this, but still it is not, yeah, your question is valid.
But then this happens
Hmm.
very rarely, I think, so it's fine.
No, but still it should satisfy our criteria, no? Because anywhere we are going to select a polygon. Okay, this is one of the method. But if I consider this, whether it works for odd, yeah, odd number it works, na? This algorithm holds good in that case
Yeah.
because number of intersect will be odd and it satisfies. Whereas in winding method, yes, as you said, it does not because here our edges is left to right. Hmm. Left to right is no change and it will remain 0. Exactly. Yes, here the condition is not satisfied. I think then the probability or there is a failure case, like it's not like 100% working algorithm, I guess. Maybe there is a probability that it may not work for few points. Or depending on the direction of your particular whatever this line segment, based on that maybe we are doing it. So if it is horizontal, then maybe this is top and this is bottom and this is left and right, things like that. Maybe we have to rotate it and see.
Yeah.
Okay, so maybe then it should work.
I
But
mean,
this one I
this
have
is,
not explored, but because you said, I'm just thinking maybe it's that is the way, I guess. If the
yeah,
same thing, if we are going to rotate it, your diagram will look something like this. Okay, at that time it will work.
right.
Yeah.
And why are we doing wrapping at first?
Sorry, actually, there is one more method. So if this is one more method called as pin elastic method, but it is not used. I wanted to explain that. Uh,
Okay, it's a
There is
different.
one more method. Yeah, it's not with respect to this. So it's a called pin elastic method. So there you are going to draw a particular, what is that? A boundary kind of thing around your polygon, and then you are going to check if the line intersect during the winding process, and if it intersect. Okay, so if this boundary and whatever line segment you have drawn, this is my boundary and this is my line segment. If it intersect, which means your point is outside the polygon. If it does not intersect, say for example your point is here, okay, if your point is here, then it is inside the polygon, like that. I mean odd and even number of intersect. If this is inside, okay, so here if you intersect here, only one intersection will be there with respect to this, whereas in this case there will be no intersection, right, if it is inside. Does it make sense? So here we have a point. Both points are outside your wrapping. So number of intersection will, in this case, it is even. Whereas if it is inside the polygon, at that time, there won't be any intersection. So intersection is only at this end, only for your polygon, the point which is or known point which is outside the polygon. Only at that end the intersection will be, not to your questioning end, and hence based on that you are going to decide whether it is inside or outside. But in our case we'll be mainly focusing on even and odd method. In the algorithm which we are going to use, we'll be focusing on even and odd method. Yeah, is it clear? So this is very rarely used, hence I didn't stress much on that. This two is clear.
Yes, ma'am.
Yeah. Okay, so this thing, you just try to explore it on your end as well. See whether we actually need to rotate it. This is what I think in so that this it should satisfy the criteria, right? So if in order to satisfy this with respect to line, maybe we have to see the top down or right and left. Then it will work. If we are going to go with this, it may not. Okay, let's see based on that. So till now we have discussed all the backgrounds, right? We understood what is polygon, types of polygon, representation of the polygon, and in that we focused on line and point approach. And then we started with an insight test to know if the pixel is a part of a polygon. So now we are going to start with our actual algorithm, that is polygon area filling algorithm. So here we have two different algorithms, that is seed fill algorithm and scanline polygon fill algorithm. We'll be focusing on scanline polygon fill algorithm, but I'll just give a summary kind of thing for seed fill algorithm. It's better to know like different ways of filling your polygon. So in seed fill algorithm, it has two types, that is boundary fill algorithm and a flood fill algorithm. So what happens in boundary fill algorithm? Say for example, I have, let's just consider our what is this? Pentagon, right? So we have a pentagon. So in case of a boundary fill algorithm, all your boundaries, okay, are filled with one color. Say for example, the boundary of my polygon is filled with one color, let's say red. So what you're going to do here is you are going to in this method, in a boundary fill algorithm, you're going to select one pixel. You're going to first identify if the pixel is inside or outside the polygon using the test method. We just discussed different test method from here, right? You're going to first decide if the pixel is inside or outside the polygon. So once you're sure that the pixel is inside the polygon, okay, let's say the pixel is inside a polygon, then we are going to make use of something called as a 4 connected or 8 connected method. In 4 connected method, this is my pixel, okay, you are going to select a pixel above, select a pixel below, left and right. So you are going to color these pixel with let's say green. Okay, let's say we want to fill a green color inside this particular polygon. We already know our border is red. Select any one pixel, use a test method and see if the pixel lies inside the polygon. If it does, then you are going to make use of this is 4 connected method. In 4 connected method, then you know already this pixel x and y value. Here you are going to increment your y value, x remains same, color that pixel. Here you are going to decrement y value, x remains same, color the pixel. In this case, y remain constant, decrement x value, color pixel, increment x value, color the pixel. So in this way, you have colored around 5 pixels. So you are going to continue like that. So this is already colored, then you're going to select its neighbor and color it, select its neighbor and color it. So before coloring, you have to first check if the pixel is already colored. If colored, ignore it. Okay, so that you are going to do. And even you are going to check if the pixel is already colored with a red color. If yes, which means that pixel is a boundary, so you need not color it. Okay, so that condition you are going to check. So first condition is if the pixel is colored with a boundary color, okay, and next what you're going to check if the pixel is colored with the fill color. So these two you have to check. If both condition is not satisfied, only then you are going to color it. Okay, so this is for 4 connected method. Similarly, in a 8 connected method, it's the same way. You have a pixel, so you have these 4 pixel, and along with this you are going to select a pixel behind, okay, behind this. So let's say it is behind, so you have to consider 3D image here. So select a pixel behind. So in this way you are going to make 8 pixel. Again, same procedure is followed. A neighboring is identified and you go on coloring them. Okay, again this condition you have to check. This is 8 connected method. So this is for boundary fill algorithm. So next is flood fill algorithm. This is boundary fill algorithm. In a flood fill algorithm, what happens is, I'll consider same diagram. So here it may have different color. Let's say this is red, blue, green, like that. So they can, there is no restriction that your entire boundary should be of a same color. Your boundary can be of different color in this case. Okay, and then you are going to what it does is it is going to fill the entire region. Okay, whatever region you have inside. Okay, you're going to select one pixel, check if it is inside, then you're going to fill it with some color. Okay, you are going to fill the entire region with some color, or in this case, and then you are going to check uh, here the checking is, say for example, initial fill is old color. Let's say initially you are going to fill the entire region with old color. Okay, and then you are going to select your or you are going to initially just fill it with some color, and then you are going to check by using again 4 connected and 8 connected method. Other things remain same. You are going to 4 connected and 8 connected method. You are going to use a recursive function, and here you are going to check okay, like whether the particular boundary, in this case the boundary color is not just one, it is set of colors. Say for example these two are together, let's say black. So we're going to ensure whether all the boundaries color are, whether the pixel have any of this boundary color. Okay, that you are going to check. If it has any of this boundary color, then you are going to ignore it, right? So you have to ignore, and only these color you have to fill. So let's, I'll just, I think it is difficult to understand that way. Can I just write an algorithm for this? So for a flood fill algorithm will look like this. So let's say I'm going for 4 connected. Okay, so initially you are going to select a point, int x, int y. So what is this point? The point wherein you are going to check if it is inside the your polygon. Okay, and then int f. What is f? F is my fill color, and int o, and o is nothing but our old color. Okay, so what you are going to do? So initially your current pixel color you are going to get. Okay, whatever x and y you have selected, whatever pixel you have selected, that you are going to get pixel x comma y. Okay, so as I mentioned, entire thing will be colored. So by default, let's say it is white color. So entire thing by default it has a white color. You are going to select that particular thing and set the color to okay. So we'll go other way around. So algorithm works like this. So whatever the current value you have got, okay, you selected a pixel, you're checking the color of that pixel. Get pixel is going to return the color of that pixel if that color is equal to old color. Okay, as I mentioned before, so all the pixel within the polygon is colored with some old color. The old color is what? By default, what is the color? It is white. Okay, so let's say we have colored it, it is white color. Then old color is white. If the current is equal to old color, okay, which means it is inside your polygon as well, then you are going to set it with the color of your choice. That is fill color. Set color with fill color and set it at a specific pixel, which color you have mentioned here and where you have to color it, so that pixel value you will mention. So in case of 4 connected, because we are going for a recursive function, so how a recursive function you are going to write? I'll just continue over here. See, this is not required, just for understanding purpose I am writing. Okay, for your syllabus we are focusing mainly on scanline. So flood fill, what is the function name I gave? Flood fill 4, right? So again, the same function is called. But in this case, what will be your x value? Let's say it is xk, right? You're going to consider yk plus 1, correct? And then this is f, this is your r. So this is your fill color and this is your old color. Whatever old color value is there, that you are going to pass. So same way you are going to consider here. So what will be the value here? Xk minus 1, Yk, B and R. So whatever region color you have specified that. Sorry, not B. I have sorry, it is not B. It is fill color, no? Fill color. Fine. So this is for flood fill algorithm. Similarly, for boundary fill algorithm, what you can write, the condition will be if the current not equal to B and current not equal to fill color, then you are going to enter, and again the same thing is done. Same inside code will remain same, only the condition will vary. In this, instead of checking all the boundary colors, what we are doing, we are going to say that inside whatever color is, whatever the default color is, so that you are going to consider, which is old color, and you are going to check if it is equal to old color, which means you have to replace it with a new color for a specific region you have specified. Let's say R is a new color, so you're going to replace with that. Okay, and if it is something other than your old color, which means it is part of your boundary, hence you are going to ignore it. And as I mentioned before, all pixel you are going to check if it is inside. Only after knowing it is inside, you are going to continue with this algorithm. Is it clear how the boundary fill and flood fill works? No? Okay, if no issue, I can do it again. So in a seed fill algorithm, first is boundary fill algorithm. So what happens in boundary fill? All edges is nothing but a boundary, right? All edges of your polygon, which is a boundary, are of same color. Whereas in flood fill, all edges are of different color. So in a boundary fill algorithm, you are going to select one pixel, check if it is inside. If it is inside, then either you can go for 4 connected or 8 connected method. In a 4 connected method, first you are going to check if the pixel has a color which is equal to your background, or if it is equal to your fill color, the color which you want to fill your pixel with. If it is no, if the condition is not satisfied, then you are going for 4 connected or 8 connected method. In 4 connected method, you are going to select the pixel above on 4 side, that is top, bottom, left and right. Okay, and you are going to color those pixel like this. You are going, with respect to x and y value, you will know your pixel position. Okay, and you are going to color those pixel. Okay, and then once you are done with this, so this will act as a reference point. With respect to this, again you are going to go for a four connected method. So again you are going to find, okay, 1, 2, 3 and a 4. But in this case, this is already colored, so this condition is not satisfied. You are going to ignore it. So whereas the pixel at the left, right and top are not colored, hence you are going to color only those 3 pixels. So like this, you are going to continue in a recursive manner till you find a pixel which is equal to your boundary color, which is red, or the pixel which is equal to fill color. If it is fill color, ignore it. If it is boundary color, ignore it. Otherwise, you are going to color it. Whereas in case of a flood fill algorithm, your edges will be of different color. Okay, you're going to find the pixel which is inside your polygon. Once it is done, then you are going to check if the pixel has a old color, whatever default color or the old color you have. You are going to check if it has that. Then you are going to start coloring the pixel with the color you have decided. Okay, whatever for region, whatever color you have decided, you are going to color it with that color with that. And this, the content is whether it has a old color or anything else. If it has old color, then color it. If it has any other color, otherwise you have to check for everything, no, whether it is red, blue, green or black. So instead of doing all that, we are checking with just one condition. If it is anything other than that, which means it is a boundary, hence you are going to ignore it. Is it clear?
Yes, ma'am.
Yeah. So next I'm going to start with the scan fill algorithm. What's the time? Okay, it's 11:30. Can we just take 5 minutes break? And then I'll continue with scan fill algorithm. Just 5 minutes break, okay?
Sure.
Okay, let's continue. So next algorithm which we are discussing is a scan line fill algorithm. As I mentioned before, here we are trying to fill a polygon with a specific color, and for that we need to find all the pixel interior to the polygon and its border, right? So that is our first thing. We want to fill a polygon. We want to fill a polygon with some color, right? You want to fill it with some color. So for this you need to find all the polygon pixels which is interior to the polygon and its border, the pixel at the border, because the border is different color and interior you want to fill it with some different color, hence you need to know both of this. So in case of general scan line polygon fill algorithm, here we are making use of the concept of the scan lines. So as you already know, we have x-axis, we have y-axis, and these are our scan lines. Okay, so here we are making use of the scan lines in order to find the pixels and fill the polygon. So here, as you know, your y value will be decreasing. It's from y max. It will reduce and x value will be increasing in this fashion. So let's consider one example. So scanline algorithm, first let's say we'll draw a polygon. Let's say I'll draw a polygon here. Okay, and you have one scan line passing through the polygon. So in this case, you're going to find the intersection point between the scan line and your polygon. So in this case, the intersection point is this and this. Okay. So we identified 2 points. So that is okay. In this case, let's say for a given value of y, for a given value of y, you know the y value because that's your scan line value, and this is a point where it is intersected. Let's say it is intersected at 2 and 8. Then you're going to form a pair, whatever the y value is there on that 2 and 8. So this will be our frame buffer. You are going to place your coordinate value in a frame buffer. Okay, and then what you're going to do is you're going to identify a pair. Okay, so what's a pair here? So let's say my y value is 4. Let's say it is equal to 4. So pair will be 2, 4 and 8, 4. Right, 2, 4 and 8, 4. So you have identified the intersection of the line of the scan line with your polygon. Okay, and then you are going to find the 2 points. Okay, and you are going to these are the 2 points. We store that in your frame buffer, and then you can arrange it in a sorted order, or sorted order in the sense in some order you can do it. Say for example from low to high values. So that is in this case your x value we are sorting with respect to x. So 2 and 8. So it's in a sorted order. So we can just draw a line from 2 and 8. So all the pixel within this between 2 and 8. Okay, that is 2, 4 and 8, 4. All the pixel here. All the pixel here will be colored. Okay, again you will go with the next scan line, identify the points, then you're going to color all the pixel value. So this is a concept used in case of a scan line algorithm. So let's consider a little bit different example. Okay, and let's say this is my scan line. So in this case you have okay, in this case we have intersection point 1, 2, 3 and a 4. 4 intersection points. So let's say here its value is 2 and here my x value is 4. In this case it is 8. Not there. Here it is 8 because it's not intersected. So then it is 12. Fine. And 12. So then you are going to fill it in your buffer. That is 2, 4, 8, 12. We need a pair. Here we had a pair, right? You had 2 points, whatever y value of y, to 2y and 8y. Y in this case is 4, hence it became 2, 4, 8, 4. 2 pair you had. You had a pair. Whereas in this case, it is 2, 4, 8, 12. Here also we have 2 pair, right? So we can go with 2, 4 and 8, 12. So between 2 and 4. So here we have 2 pairs. Between 2 and 4, again if I'm considering a y value, say for example y value is 9. it will be 2, 9, 4, 9. So this is one pair. Then you will have 8, 9, right? And 12, 9. So this is my second pair. We are going to sort it in an order. It's already in order. It's 2, 4, 8, and 12, right? It's already in order. So between 2 and 2, 9 and 4, 9, you are going to fill the colors. Here. And then between 8, 9 and 12, 9, you will fill color. Fine. So like this, if you have one more line, and okay, 2 points, then you're going to fill over here. See, while showing this diagram, you can see there is a space, more space here. But in actual scenario, the space between the scan line is very negligible, and hence you cannot actually see that the place is not filled. Okay, so the scan line are very near to each other, and hence it look like the entire polygon is filled. So that you have to keep in mind. This is just for understanding purpose. We are giving this much space. Okay, so this is one scan line and the second scan line. Based on that, when scan line is used to fill the polygon, there are different cases which need to be considered. Okay, when scan line is used to fill polygon, we are going to consider different cases. So I'll be discussing the cases with respect to examples. Okay, I'll consider the same polygon. Let's say this is our scan line. Sorry. So in this case, how many intersection point we have? 3. And let's say this value to 8 and a 12. Okay. So can we have a pair with respect to this? Is it possible to have a pair? No, right? Here we don't have pair because we have 3 set of coordinates. How can we have a pair with 3 set of coordinates? You need to have at least even number of coordinates, right? In order to have a pair. So here what is happening is your scan line is passing through a vertex. So this is a condition when your scan line is passing through a vertex. So this is a vertex, you are passing through it. Okay, hence we are getting odd number of coordinates. Right, we are getting odd number of intersection point. So how we are going to consider it as a even? We have to make it even. Here we are going to consider that vertex, whatever the vertex you have intersected with, is considered as 2 intersection point. Okay, so hence you are going to write it as 2, 8, 8 and a 12. Again, why I am considering it as 2 intersection point? I think we have discussed in somewhere here, right? So when you are passing through this, we consider it as even, right? So even is it's, let's say even is 2, right? So this is considered as 2. Even plus 1 is odd, hence you said it is inside. So you consider it as even when the edges are in the same side as same side with respect to your scan line, with respect to your line segment. So using the same concept here, if the edges, whatever edges with respect to this particular vertex, if it is in a same side with respect to your scan line, then you are considering it to be 2. Okay, 2 intersection point. If it is at a different side, then it is considered as a 1. Okay, so hence in this case, because they are in the same side, you are considering it as 2, and hence we have a pair here. these 2 points and these 2 points you are considering. Fine. So next, second case. So this is one vertex, two vertex, things like this. Okay. So let's say this is my scan line. It's the same condition like this. Here also your scan line is passing through a vertex, but the vertex is what in this case? Let's say the value, the intersection point here it is 2 and here it is 12. You already have a pair. So in this case, whatever the vertex you are passing through, okay, whatever vertex you are passing through, so edges are at a different side of your scan line. Hence you are considering it as 1. So 1 and 2, only 2 points are considered. Whereas in this case, the edges, that is your E1 and E2, are at the same side of your scan line. Hence it is considered as 2. Okay, this is considered as a 2. So 2, 3, 4, which means you have 4 intersection point. In this case, it is considered as only 1. Hence you have only 2 intersection point. Okay, here you have even number of intersection. Hence vertex is considered as one intersection. Okay. So these two cases, remember, even though it is passing through a vertex, you have to see to it that you are getting only even pair. If it is you are getting odd pair, then you have to see we can split the vertex into something like this. Your same vertex can be used as a intermediary between 2 points. Hence, you are rewriting the vertex twice. In this case, it is because we have only 2 intersection, and you can see the edges are in this way, and it is considered as a one pair. The only thing is you have to make sure that you have pairs. So next is yeah. So there is one more method. This is one way, and there is one more method is okay. Yeah, I'll just show one more method. Okay, so this is our point. This is our scan line. So one more method is by traversing the edges. Okay, this is by traversing the edges either in a clockwise or in a anti-clockwise direction. If I'm traversing the edges in a clockwise direction, so let's consider that this is 12. Okay, so if I'm traversing in a clockwise direction, here you are going to observe the y value. Okay, whatever y value is there, you are going to observe that if sorry if the value if the y value if the y value is monotonically decreasing, then consider it as consider it as one intersection point. Okay, so this is our y value. So this is our intersection point. So now you want to decide whether I have to consider it as 1 or 2. This is one method. This I already told you, right? So in this method, this is using a clock or anti-clockwise direction. If I'm using clockwise direction, then you have to check. Okay, if this is an intersection point, whether the y values, observe the y values, if the y values is decreasing, okay, if it is decreasing, okay, with respect to intersection point, then you're going to consider it as a 1 point, as one intersection point. If it is decreasing, the y value is decreasing, right? If it slowly it is decreasing in this way. Whereas if you consider this example with respect to intersection, here the y value is decreasing, here the y value is increasing, right? So the condition is not satisfied. Hence we are going to consider it as a 2. Whereas in this case, the y value is decreasing when you are going for clockwise. Similarly, when you are going for anti-clockwise, you have to check if the y value is same diagram. You have to do in a other way, something like this. A diagram will look like, okay, so something like this you will do, and this is not this. Let's say this is our point, right? So this is our intersection point. So you have to check in this way. In this case, when you are going for anti-clockwise, your y value is increasing. Okay, if in this case the y value is increasing monotonically, in case of anti-clockwise direction, there also you are going to consider it as a one intersection point. Is it clear?
Yes, ma'am.
Yeah, because when we are going like this, your y value is decreasing, your y value is increasing, right? Both cases you can see in this case. It is decreasing and also increasing. Hence, we are considering it as two intersection point, whereas here it is either decreasing or increasing, and we consider it as one intersection. So whatever you're comfortable in, either go with this, just make sure answer will remain same. Either you are going with a clockwise or anti-clockwise method, or you're going with this, like you can find a point and then see if where the edge lies and accordingly make the decision. Okay, so keep this in mind. So based on this, let's see your scan line algorithm. So first thing, you are going to locate the intersection point of the scan line with the polygon edges. Okay, we have seen here, this is our polygon, edges. These are our scan line. You are going to locate the intersection of the scan line with the polygon edges. Then pairing the intersection points. So that also we have seen. Okay, whatever intersection point is there, you are going to form a pairing out of them. Then move down as per the scan line and sort all pair. Okay, this I showed it for one scan line. Similarly, you will have second scan line, like that. Go on with every scan line one by one and find the intersection point at each scan line and sort it in a order. Once all pairs are sorted from Ymax to Ymin, because we are going from top to bottom, right? You're doing the scanning from top to bottom. Hence, once you are done with the scanning from top to bottom and you have sorted in that order, then sites are sorted on intersection point. You're going to sort all the sites with respect to intersection point. Then you are going to fill the color. So once you have all the pairs at each scan line is what? It basically represents y value. At each y value, you have all set of x and y pair of intersecting points in a sorted order. Then once it is done, then you are going to fill the color within all the pixel inside the pair. You already have a pair, right? You already have a pair. You are going to fill the pixel values. That is our last step. Between the pairs, you are going to fill your pixel values. So this is scan line algorithm. So what we have done here, first thing, locate the intersection point of scan line with polygon. First imagine this scan lines. Okay, we have different scan lines. Place your polygon, see where it intersect. At every line you have to see where it intersect, and you have to identify all the pairs, the intersection points. And if intersects on the vertex, then apply the condition or the rule as specified. and then you are going to arrange it in a sorted order, in a sorted order with respect to each scan lines. And once that is done, you are going to fill the color. Is the algorithm clear or the steps clear? We are going to solve problem based on this. Just see if the step is clear. Is it clear?
Yes, it's clear.
Yeah. Okay, so just remember this because now it's already time. Based on that, we'll be solving this problem in next class. Okay, so here the question will be something like this. Determine the content of the active edge table. So that will see what do you mean by active edge table. It is basically the pairs which you will identify at each intersection point to fill the polygon with vertex. So the vertex is given, that is 2, 4, 4, 6, 4, 1, right? So if you have to first draw the polygon like this. You have x value and a y value. You can just give values. X value, what's the maximum value we can have? 2, 4. Okay, 4 is the maximum value we can have. So let's say this is 1, 2, 3, 4, and 5. And y value is 1 to 6. 1, 2, 3, 4, 5, 6. So just to draw a polygon, that is A is 2 and this point, right? And next is 4, 1 and 4, 6 is there. Let's say here. So this is our polygon. Excuse me. So we have this polygon and 3 different points. This is my A and this is our B and this is our C. So this is given, okay, they have given this. So our job is to fill this polygon. So you will have different scan line and you have to identify the intersection point and fill the polygon with the color specified. Okay, so that will be doing in next class. If you have any doubt, you can always ping me. Okay, next class this Saturday you have your quiz. Okay, and it is October 2, hence you will not be having theory class. Instead, you will have only quiz. So quiz, because our class is from 4 to 5:30, I'll schedule you a quiz at 4 o'clock. Okay, make sure you don't forget to give your quiz. And portions,